There's a lot of talk today about splitting monolith services into microservices. And so I want to talk about that too. A monolith, of course, is typically what people have had in the past, where they've written all their code in a single service. So if you look at the example I just gave, we have the website service, we have the order taking service, we have the inventory service, and we could write all the code for those services in a single monolithic service, and we could go and deploy that into a cluster, and we could deploy it with multiple instances. But there's this effort nowadays to not do things that way, and to take the code and to split them up into different microservices. On this slide here, I want to talk about the reasons why you would consider doing this. Now, I have spent a lot of time thinking about this particular problem and talking to a lot of customers, and I can identify 4 reasons why you would consider splitting a monolith into microservices. The first reason, which is probably the most important to many people, is to give you the ability to scale these services independently of one another. And what this really is providing you is the ability to balance cost with performance or speed. So let's take, for an example, a photo share service. This is the service where your customers, they upload photos into a service, and then they can go and share those photos with their friends and family. So then they can look at those photos later. Now, when you're uploading these photos into the service, there's also a thumbnailing service that has to go and take those uploaded photos with their full resolution and produce smaller size thumbnail images of them. Well, the photo share service, the front end, if you will, which is the main website for this application, it's going to have people uploading photos, and it's also going to have people just looking at photos on it. And so we might need to scale this service onto lots of different machines depending on how many customers we have. Now today, if we're building this service, we might not have very many customers. So we would probably have at least 2 VMs, right? You typically want at least 2 instances running, so if one fails, the other one takes over. If you have just one, again, it fails, and then clients can't be served. Right? So if you have 2, one fails, there's a short period of time before it gets, the orchestrator fixes it and brings it back online. In this case here, I'm showing that I have 4 instances of it running. That's what those 4 rectangles mean. So now, the thumbnailing service, however, is only needed when people are uploading photos. Right? If you're uploading a lot of photos, then I need to create a lot of thumbnail images. If people are just looking at photos and they're not uploading photos, then the thumbnailing service, we don't need to have a lot of instances of that running at all. So the number of instances of the thumbnail service really depends on how the service is being used, and more specifically, are there a lot of uploads happening, or are there just a lot of viewing of photos that are happening? So by separating the code for these 2 workloads, if you will, into 2 different services, the photo share front end service and the thumbnailing service, we can deploy them onto different VMs. And it may be certain times of year, like the holiday season, where people are taking more photos, we might need to scale the thumbnail service up. So now I'm running 3 instances of it. And maybe at certain times of year, when people are doing more viewing and not as much uploading, we can go and scale it down. So now I've scaled it down by 1, so only 2 instances of it are running. So this, I think, is the most important reason why to consider splitting a monolith up into multiple services. But there are other reasons too. The second reason, which I think is the second most important reason, is because you might want to use different technology stacks. Imagine at the photo share service, we want to write the code for this in, let's say, Node.js. And let's say for the thumbnail service, we want to write the code for that in .NET or maybe Java. Well, in order to use these 2 different technology stacks, we really need to separate this out into 2 different processes. And then the 2 different processes would run on different machines, and we would talk to each other through a network connection, like as shown by this arrow over here. So that's another reason why you might want to split things up into microservices. You want to use different technology stacks. And this can also be actually the same technology stacks, but different versions. Maybe I want to use, version 7 of Node over here, and, version 20 of Node over here. But they have different dependencies involved. So that would be another reason to do this. A third reason to split a monolith into microservices is because you might have 2 or more clients that want to talk to the same service. This is similar in object-oriented programming where you have a base class and then maybe you derive one class off of it and derive another class off of the same base class, right? You write the base class once and then you get to reuse that functionality in all these derived classes up above. This is very similar to that. So here I have the photo share service, version 1, and I have a video share service because maybe when you upload videos, I also need to create a thumbnail image of some frame of that video. So they might both require this thumbnailing service over here. So we can split these all up into a bunch of different microservices so that we don't have to have the thumbnailing code, repeated in multiple places. This also allows us to version these services on their own independent schedule. Right now, the thumbnailing service is version 1, and the photo share and the video share service, they're talking to version 1 of the thumbnail service. But it could be who makes that thumbnail service could go and bring it down and bring up version 2 instead. Now, of course, whenever you do this, version 2 must be 100% backward compatible with the earlier versions, because the photo share service and the video share service, they still think they're talking to version 1. So this version 2 can support new features and add new APIs that are available, but it must also support the version 1 set as well so that these guys over here can still continue to talk to it. But then these clients, they can adopt these new features at will. So we could have the photo share service, update to version 2, but the video share service could still be using version 1. The fourth and last reason why I can imagine splitting a monolith into microservices, and this is a pretty esoteric reason here. This is absolutely not a common scenario, but it does happen in real life on occasion, and that is what I refer to as the conflicting dependency scenario. Imagine that we have this photo share service, and imagine that we're building it right now as a monolith. And it happens to use some shared library, version 1. Now, because it's a monolith, we're going to put the thumbnail code inside here and deploy it all as a single service, maybe multiple instances of that service, but as a single service within our cluster. And this thumbnail code, it might use the same shared library, but it may have a dependency on version 7 of that library. Well, with a lot of technology stacks like .NET or Java, you can't load two different versions of the same library into a single process. So you do have an option of maybe taking the photo share service and having it assume version 7 of the library so we can really merge these two things together in here, but that may require a lot of code changes in order to do that and a lot more testing that you're prepared to do. Obviously, you can't take this shared library and go back to version 1 of it because the thumbnail probably is using version 7 and requires that. So there's really no good solution for this problem if you keep it a monolith. But a way that you can solve it is by splitting it apart into microservices. So let's take the photo share service and we'll make it its own service, and it can use the shared lib version 1. And let's split the thumbnail service into its own service, and we'll have it use the shared library version 7, and then we can communicate between these two, again, using networking communication in some fashion. These are the 4 reasons why I think it's useful to split a monolith into microservices. But let me say a little bit more about this. A lot of times when you go online and you read what people have to say about microservice architectures, they give you a laundry list of benefits that they provide you. I've, again, spent a lot of time talking to customers about this and building these kinds of applications myself. And I feel that a lot of the benefits that people tout with microservices aren't actually benefits of microservices architecture at all. And so I refer to these things as myths, not really as benefits. Let me give you an example of 2 of the big ones. So a lot of times if you read about microservices, people will say things like microservices offers small, easy to understand and manage code bases. And this does sound wonderful. And it is wonderful to have small, easy to understand and manage code bases. But it's not really microservices that provides this. We have had things like object-oriented programming for several decades now, and this was one of the benefits of object-oriented programming through those past several decades, where people would say, split your code up into these little classes. Each class is a small piece of code that's easy to understand and easy to manage. And so microservices architecture maybe forces you to do this to a greater extent, but isn't strictly necessary in order to do this. We've had ways of doing this for many decades now. So as I say on the slide here, a monolith can use object-oriented programming, or it could split things up into libraries and just take a dependency on a bunch of libraries. And really all that this requires is developer discipline. It does not require a microservices architecture. Also, I like it when you make a change to a library and then when you build things and it fails. Build failures are good as opposed to runtime failures. Because if it doesn't build properly, you know it's not going to run properly. And it's better to find out when something doesn't work at build time rather than when it's deployed into production. So there are some benefits of keeping things as a monolith that has local libraries that it's using, because if you make a change to a library and then you rebuild and it doesn't build correctly, you know that there's something wrong. Whereas if you split the monolith into different microservices, you might build this service fine, but now the other service that's calling into it, it hasn't built against that library directly, and so it thinks everything's okay, and you'll find out only at runtime that something went wrong. Another myth is that a failing service doesn't impact other services. This one's also touted quite a bit, where if you split things into microservices, one service could go down and everything else keeps running fine. Well, a lot of times that doesn't work practically because many services require dependencies to be fully functioning. If your authentication service, for example, where you authenticate users, it goes down, a lot of times there's very little that a user can do on your service if the service doesn't know who they are. That's not always. There are some times when you can do things. If you go to an e-commerce website, if you don't log in and say who you are, you can probably still see the products they sell, read the descriptions, you just wouldn't be able to place an order. But on some other websites, there's very little you can do unless you are authenticated. Also, it's very hard for developers to write and test code that gracefully recovers when a dependency fails. So while this may sound good again, that a dependency fails and you keep up and running, very few people actually write the code to test that scenario and make sure that it's resilient and robust. In which case, you may end up just failing in production again, and that's not really the best place to fail. But this third sub-bullet here is probably the most important one. We run multiple service instances, so there's no such thing as failure. Remember, in this distributed cloud application architecture, we are embracing the concept of failure. We run our service on multiple VMs so that if any one of them goes down, we can still get to other ones and keep going. So if we design our architect our service that way and we use an orchestrator that helps us with this, then there really is no such thing as failure because the orchestrator will heal whatever has failed and get you back up and running. So again, I don't think this is more of a myth to me than it is a real benefit of a microservices architecture. Also, a monolith is either up or down completely. Right, so there is no recovery code that you have to write. There is no recovery code that you have to test. And the orchestrator restarts failed instances, keeping them up all the time. What I'm trying to say here is that sometimes it's better to be 100% up or 100% down as opposed to 50% up and 50% down. Right, because when you're in that half state there, you don't really know what's functioning, what's not functioning, and how things are going to work. So again, if you're designing for failure and the cloud, you will have multiple instances, and so you've already designed things to be failure resilient. My last bullet here is that many of the promoted benefits are really about forced discipline, and we have them even without adopting a microservices architecture. Right? So a microservice architecture is not absolutely required for a lot of these benefits. The main benefits are what I showed on the previous slide about independent scaling, about different technology stacks, about independent versioning or having multiple clients talk to the same service, and about using that different versions of conflicting dependencies. Right? Those are the main benefits of a microservices architecture.